The add item function. The function is pretty simple. We just check some parameters, some incoming parameters to this function, and we store in the dApp key value storage 3 key value pairs. But you may wonder why I defined so many functions to construct keys. The answer is pretty simple. We will use those functions in the next user functions, in the next callable functions. For now, let's try to implement the purchase function for customer. We are working mostly with the dApp key value storage, so we will have to implement, again, we have to implement some functions to construct proper keys, and we also will have to implement functions to read the value from the storage. In the previous lesson, I skipped the part when we try to find the supplier and we will try to find an item by this supplier. I skipped that part. So now we will talk a bit more about how to read the data from the key value storage. There was a function called getValueItemSupplier, and this function calls another function getStringByKey. Let's try this to find this function. Here is it. This getStringByKey accepts one parameter, the key, and tries to read using getString function, tries to read the value from the key value storage, and if it finds the value, then it returns this value. Otherwise, it returns the non-value. The function is pretty simple, so please note we use here pattern matching. So this is the basic and very simple example how we can use it. We can say if you find the value with type string, then return it. Otherwise, with all other cases, return none. Okay, let's go to the purchase function finally. Let's try to describe what it should do. So user should invoke the purchase function with an item ID he wants to buy. So we will call this purchase function and provide an item ID, the string parameter. The contract should check and should do a couple of things. First of all, we will require Waves tokens as a payment. So users will be able to buy only with Waves tokens, not with any other tokens. We will also check the invocation object. We will find the amount of tokens attached as a payment, and we will check that supplier expects exactly this price. We will allow to buy only with the same price, not even higher. And we also should check that supplier exists, that item exists. So let's implement that. First of all, we will define some variables we will use a bit later. We define here user address. We get it from the invocation object. We also get the price. We read the price from the key value storage. Let's check what is the getValueItemPrice function. Here is it. It just reads the integer value. The family of get functions is very, very interesting. I think we can talk about them a bit more. There are 4 main functions like get integer, get boolean, get string, and get binary. But all of them will return an option. It means that if we try to read some data from the key value storage and there is no data, we will get one of 2 values, one of string, boolean, byte array, or integer values, or nothing. So we will not get an error immediately. We will have a variable with option inside it. So to get an actual value, we have 2 options. First, we can use pattern matching as I used before. Another option, instead of using getInteger function, we can use getIntegerValue function. What's the difference between getInteger and getIntegerValue, for example? GetIntegerValue will throw an error if there is no value in the key value storage, while getInteger function will return an option. That's the difference. In this case, we say that we always expect a price for the item. So we will definitely try to find a value for the price. If there is no price, it is an error. So we will just stop the execution of the smart contract. So that's why here I use getIntegerValue instead of using pattern matching as I showed before. Great, we will have the price of an item in this variable, and let's get the supplier's address. How to do that? We have here getValueItemSupplier. It is pretty simple. Tries to get some value using some key. What is the key? The key is also simple. We try to get the item ID plus underscore owner. So as you may remember, it looks like this. So we will try to get this address, supplier's address. Great. Now we have some useful variables we will use later. We check the price and the amount of tokens attached. So we say that if the amount of tokens attached is less than the price, then we throw this error. If it's more than the price, then we throw another message. And if there is no supplier, if we got none instead of supplier's address, then we throw an error with this message. Sounds pretty simple. As a next step, we have to do a couple things. Let's think. First of all, when we try to buy an item, the supplier should get those tokens, should get money, and customer should get his own coupon, right? So how to implement that? Let me show you how our dApp state can look like. So we have some item, 3 different key value pairs about an item. When user wants to buy an item, we can create a new key value pair with the item ID and with underscore CNT or count. Why? Because customer is able to buy the same coupon many times. So we will just increment this value. By default, it should be 0, or 1, 2, 3, etc. So if you buy a couple of times, then we will increment this value. When we use the coupon, we will just decrement the value. What about the supplier? They should get money, right? When a user buys an item. So we will not transfer immediately the tokens to the supplier's address. We will store those tokens on the smart contract. So we will have a key like supplier's address underscore balance, and we will increment it every time when somebody buys this supplier's item. So it means that in the future we will have to implement the withdraw function, which will allow suppliers to withdraw their funds from the contract. But in that withdraw function, we can implement some custom logic. For example, that escrows should validate that this supplier is not fraudulent or something like that. So now let's try to implement the basic operations. Let's try to store the number of coupons bought by one user, and let's store the balance and increment the balance of supplier when user buys an item. So to do that, we have to first of all get the current value of this counter and increment it by 1. So what are we going to do? We construct the proper key. The key should look like this, as you may notice. So we construct the proper key. We get the value from the dApp storage by this key. So let's check this function, how it works. It tries to get the value If there is a value, it returns the value, otherwise it returns 0. And we increment this value by 1. Looks pretty simple. And we will store it in the dApps key value storage. So we have this key and this value. Almost the same thing we do with the balance of the supplier. What are we going to do? We will construct this key first, and we will increment this number second. Of course, if this number exists in the key value storage. So we construct the key, and we try to get the value. If there is a value, we get that value, otherwise we get a 0. And we add to that value amount of tokens attached to the current purchase operation. Sounds pretty simple, right? Now let's try to write some more tests and to run the code, to run the tests actually. As you may remember, I already implemented an add_item test function. Now I implemented the purchase_item test function. Here I define an item ID I want to purchase. I construct the invoke script transaction and send it to the network, broadcast it, and wait until it goes to the next block. Let's try to run both of these functions, but before we have to deploy our smart contract. The easiest way to deploy a smart contract is to use the deploy button here in the IDE. As you can see, it just shows the parameters of transaction. We can add a signature and send the transaction. Here are different options how we can provide an account to sign this transaction. An IDE has its own account storage built in, which you should use only for development purposes, of course. Here I have an account with some Waves balances in the StageNet. You can create a new account and you can get free StageNet Waves tokens from the faucet in the Waves Explorer, wavesexplorer.com. There is a faucet page. You can paste here your address and get some free tokens. I already did that. So now I will deploy this smart contract on this account. Let's do that. Deploy, let's add the signature and publish the transaction. It says that transaction has been sent. Here is transaction ID. Let's go to the Explorer. Please make sure that you use the proper network. Here's a StageNet. When you use faucet or when you use the Explorer, make sure that you use the proper one. Let's see the compiled version of contract. Looks like ours. Great. We already deployed the contract. Now, let's try to run our tests. But before we do that, we have to put our dApp address here. What is a dApp address? I deployed it on this account, so my dApp address is this. And let's put it in another function as well. Great. Now let's run this add_item function. I have to note that this function should return an error right now. So let's see. Error while executing account script can't apply something. What is an error? This is a very common error for newbies. Let me check arguments. In the previous lesson, I said that we have 3 arguments that are in correct order. There is a title, right? Let's check add_item. There is a title. There is price, coupon price, and there is data. There is data. Great. But let's check the types of the variable for now. The title is string, obviously. The coupon price is string, while we have an integer value in the contract. So that's an error. We have to fix it. Just change the type to integer. And let's try to rerun the test. Great. It says that test was successfully passed. Let's go to the Explorer and try to find what is in the data storage of an account. I found this account in the Explorer. Here's a data tab. Great. I have 2 items To be honest, I already added one item before. So now I have one new item. Here is it, t-shirt, coupon price, old price, the owner's address, the price of the item. Great. Now we will have to use this item ID, as you may remember. We have to pass this as an argument to our purchase function. Let's copy this value and paste it into our purchase item test. Here is it. So let's run this function and see the result. It takes some time because the transaction really goes to the blockchain. It is not a simulation or something like that. It really goes to the blockchain. Great. Now let's go to the Explorer, update the page, and see what's happened. As you may remember, here's our 7DI9. This is our item ID, 7DI9. And now I have this key, that item with ID 7DI9, blah, 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 was bought by user with address 3MT4Q. Let's check my address, 3MT4Q, great. How many times? Once. I can rerun this function, update the page, and there is 2 right now. So we implemented the very basic add item and purchase functions.